Okay, I will run this code line by line so that you may understand that what I have done. First I will run it completely, and you will see the results. These are the actual results that you want me to display. The first one is the data, the carbon dioxide intensity per kilowatt hour, which was in the Excel sheet. So these are the time axis, and this is the gram carbon dioxide in gram per kilowatt hour. And here are two plots. The blue one is the carbon dioxide intensity for the complete set of data, and the brown color line, this is the average, which is the threshold that we will be using, and this threshold has been used for the 24 hours. Like the complete one day, for the complete this one day, the average is this value. For the next complete 24 hours, the average value is this one, and so on. This is the charging and discharging status. This color represents the charging and other color represents discharging. You can see that sometime battery is charging for a certain duration, then it gets discharging, and so on. And for some time it's neither charging nor neither just discharging. This is the another plot which represent the carbon dioxide intensity in gram per kilowatt hour when battery is charging and discharging at that instant. So I will run code line by line now, so that you may see that what actually is happening. In the second line, I have loaded the carbon dioxide data from the CSV file that you have provided me. You can see that a table has been created, and in this table, this second column represent the carbon dioxide intensity values. The other columns represent date and the locations. So I have to collect data from the second variable, which is variable 2. So I have used the dot operator to extract data from this structure, from this table. And when I run this, you will see that only one column, which represent the data, which contain the data, has been loaded over here. I have taken the inverter as 1 megawatt hour, and the battery capacity is 1 megawatt hour. Inverter is 1 megawatt and a capacity is 4 megawatt hour. So the charging time, complete charging time, will be capacity divided by inverter, which is about 4 hours. It will take 4 hours if we charge battery from zero capacity to full capacity. Now, since in the Excel sheet you can see that the data samples have been collected at each after 15 minutes. So 15 minutes is 25% of the complete hour. So within 15 minutes, 25% of the inverter capacity will be used to charge or discharge the battery. So this one represent the charging or discharging value in 15 minutes of duration. So the average power which I am using is 550, but this is of no purpose, so I am going to comment it. I am not using this value anymore. This is the discharge variable which will be used in the future. Charge variable status, grid carbon dioxide at charging. These are variables which your professor has provided you to calculate data, for which you have to create code and calculate data for these variables. So I have defined all these variables over here at this position. This is the grid carbon dioxide at charging, which is this one, and then the average power, which I have to calculate. Average power will be calculated for each 24 hours. So there are a total of 96 samples per day, so 96 samples have been used to calculate the mean of each 96 values stored at the average power variable. So the total number of days are 29. When you study the detail of the Excel sheet, you will see that there are 96 samples per day and the total data is for 29 days. The data has been extended for 24 hours then, and then it has been reshaped. This data has been reshaped again. For each day, the threshold value remain the same. When the day change, the threshold value changes. Like you can see that this is 436, and below this 96 sample, 97 sample is 598, and then it changed to another value which is 680. So these are the threshold value for each day. I have to plot the figure of the data. So this is the raw data. This is the carbon dioxide intensity in gram per kilowatt hour, and this is the time. These are the labels like X, Y, and legend, etc. This is what I have explained, that for 24 hours threshold value remain the same for each day. And then I have created a loop for other calculation. The loop will run for each set of data and will run for the 2784 times, and it will study if the carbon dioxide intensity value is above the threshold value of that day. If this data is above the average value of that day, then this portion of the code will get executed, and it will study if the charge is not zero. If battery has certain charge, then it will, if a battery has certain charge, like it is not zero, then it will discharge the battery. The discharging status will be this one, that for within 15 minutes how much battery can get discharged, and the charging value, like the value at this column will be 0, and for this will be minus some value. If it is not so, then both of them will be 0. It will check if the battery charge is not above the threshold, which is the average threshold value. Then it will check if the battery capacity is not fully utilized. If it is not fully utilized, then it will make the charging status a positive value and discharging as 0. And if it is not so, then both of them will be 0. Again, it will include, like this one is the status of charge. It will include some it will add the charge or discharge percentage with the current status. If it is going to discharge, and then there will be a negative value. If it is going to charge, then there will be a positive value, and the status will be updated. Similarly, the grid at charge, which is the product of the charge multiplied by current data, and the discharge multiplied by current data, it will be updated, and all these figures will be plotted. This is the charging, at which time the battery is going to get charged. And this is the charging and discharging in the same plot. Sometime battery is charging and then it stop charging, then it start discharging, then it stop discharging, then charging, and so on. And this is the status for the charging and discharging. Like the battery is going to increase its charge, its capacity is fully utilized, and it start discharging, it fully discharged, and then it's again going to charge, and sometime it's going to charge and then start discharging, then again charging. So this process gets continued. So this was all what your professor has asked you to create, and I am not using the graphical user interface over here because he has told you not to use the GUI portion.